Good morning, everyone. My name is Pushpanjali Pandey. I will be giving a presentation on energy efficient design of RAM and its implementation on FPGA. The topics I will be discussing today are presented as follows. Introduction, related work, energy efficiency, thermal analysis, conclusion, and the future scope of this research. Overview. There are many systems which use RAM as its primary memory. For example, a spacecraft, our home, computer, etc. Energy efficient RAM in is even more important in outer space exploration as the power source is very limited and the environmental condition is extreme. Energy efficiency is not only based on the architecture of the system but also on the environmental condition. For that reason, low power RAM will increase the performance of the system even in extreme conditions. Introduction. In this work, we are going to create a RAM that aims to decrease the power usage and therefore make it more energy efficient for serving the same purpose. To make the RAM energy efficient, we are using low voltage complementary metal oxide semiconductor. The RAM which is to be designed is actually implemented on FPGA which is field programmable gate array which is an array of gate and can be used as per the requirements of a programmer to alter its function accordingly. Different FPGAs used in our research include 28 nanometer process technology, RTX 7, Kintex 7, Kintex 7 low voltage, and Spartan 7. Energy efficiency. Using the mentioned FPGA, for example, implemented of RAM, we have calculated its overall power consumption, dynamic power consumption, and leakage power consumption by simultaneously varying the values of output, load, and keeping constant frequency at 1 gigahertz and constant temperature at 25 degrees Celsius. Thermal analysis. Using the mentioned FPGA for implementation of RAM, we have calculated its overall power consumption, dynamic power consumption, and leakage power consumption while simultaneously varying the values of temperature and keeping constant frequency at 1 GHz and constant output load at high picofarad. Conclusion: Arctic 7 FPGA is the best architecture of low power design of any RAM and FPGA in case of total and leakage power consumption. But in case of dynamic power consumption, Kintex 7 low voltage FPGA is the finest architecture of low power RAM design on FPGA. Future scope: In future, we shall write Verilog code of heterogeneous architecture and circuits related to RAM in Verilog. In this project, we are using 4 7 series FPGAs. In subsequent research, we may use 16 nanometer process technology based ultra-scale for FPGA for design of RAM and other hardware. We have only applied capacitance scaling and temperature scaling to develop the low power design. In future, we shall use different low power techniques, for example, voltage scaling, IO standards to develop low power design. Reference. Reference. Thank you everyone.